Here's the key to your test review. I know there was kind of a lot of questions on here, but I wanted to make sure that you had, a little bit of everything going on here. And there were some edits along the way, because, good Lord, I don't know what the heck goes on here, but this clearly, I think you could have told us supposed to be those brackets. All right, so we're supposed to determine whether this sequence is arithmetic, geometric, or neither. If arithmetic or geometric, we have to give the common difference or the common ratio. So remember, you have to check these, not just the first two terms here, but you got to check, the second two as well, at least. So it looks like the numerator is staying the same, the denominator is changing. I'm thinking we're probably multiplying by something. And if I take 5 and I multiply it by 1/6, I get 5/6. And then if I multiply again, I get 5/36. So there we go. So you can figure it out kind of going forward if you just can see what the pattern is. Remember, if you can't, if they're obscure numbers or something, I would have to take this fraction, divide it by this fraction, get what my number is, take this fraction divided by this, get this number, and then to see if they're the same. So they are the same, and since we're multiplying by 1/6, it is geometric, and that 1/6 is my common ratio. All right, so number 6 here. Since the signs are alternating, it cannot be arithmetic. It would have to be geometric in order for the signs to switch, because we'd have to be multiplying by a negative, which will flip the signs back and forth. Well, 1 times a negative 16 is negative 16, and negative 16 times 81, times what is 81? Well, it's definitely not 16. And if I did 81 over a negative 16, it's going to be different than negative 16 over 1, so it doesn't even really matter what that number is. This has to be neither. All right, so then this next one here, well, the signs are the same, different, which means we can't be multiplying here, so it can't be geometric. But it looks like here I would be adding a number. And there was on the quiz, there was a quiz like this, where there's a question similar to this, and a lot of people miss the sign on that because here we're adding 7 every time. But the people put -7 because of the negatives there, but you're adding it. That's why the number is getting bigger. So this is arithmetic, and D is equal to 7. Okay, so then it says write an explicit and recursive formula to find the nth term of each sequence. Well, wow, that was just a hot mess on that quiz too. Explicit versus recursive, okay? And some people say, well, I just couldn't remember which was which, but would get the explicit 100% right, and recursive, I don't know what the heck was going on with that thing. But, so we'll just start off figuring out what's going on first. So it's telling me to do this, not asking me if it's an either. So this is either arithmetic or geometric, right? Well, I can see here that I would be multiplying by 2, and I'd be multiplying by 2. So this is geometric, right? Geometric. R is equal to 2. So I use my formula for geometric, which is going to be, and that's where the explicit comes in when you write the formula that will work no matter what you plug in for n, and I could find the 50th term without finding terms 1 through 49. So your explicit, a sub n, is going to be equal to a1, which is -7, times r, which is 2, to the n minus 1 power. Recursive is when you're pretty much just explaining the pattern. So I'm multiplying by 2 every time. If you know that that's the pattern, you can find the next term if you have the one before it. So I have to define the first term. The first term is -7. To find any other term, so like an, whatever term I want, I have to have the term before it, which is a sub n minus 1, times 2. Okay, and we usually put the multiplication in the front. So it's 2 times the term before it. That's what that means. That's how you explain it, what it is, and that's what this says right here. And when you're writing this stuff out, you better watch your handwriting, because some of y'all had this as exponents, some of you had it, I couldn't tell what it was. So I couldn't tell if your handwriting was crazy or if you didn't understand what the heck was going on. I think for the most part it was that you didn't understand what the heck was going on. But since we are defining this, we defined A1, n has to be greater than or equal to 2 in order for this to work. There is your explicit and your recursive. Okay, number 9. So the things that needed to be fixed on this review were fixed before I imported it here. So this is something that y'all were missing. That one you could probably figure out, but all kinds of things disappeared and spacing. I don't know. I give up. All right, so then I have to decide what's going on here, thinking I'm not multiplying by anything. I mean, again, you can check them by actually dividing and figuring out if it's geometric or arithmetic, but I mean, what would I multiply 13/6 by to get 17/6? Because that just doesn't even make any sense. So it's going to have to be arithmetic. So again, you can use the calculator to help you figure this out. Do 13/6 minus 3/2. And then you can do 17/6 minus 13/6. And you should get the same answer both times, right? You're going to get that D is equal to 2/3. Right? So for and this is arithmetic. So for arithmetic, AN is equal to the difference, which is 2/3, times n minus 1 plus A1, which is 3/2. A1 is 3/2. So then we clean that up a little bit. When I distribute, I'm going to get AN is equal to 2/3 n minus 2/3 plus 3/2. Once you get common denominators and do the thing you need to do there, you're going to get AN is equal to 2/3 n plus 5/6. So no matter, I could find A sub 50 right here. Substitute in 50, boom, there's my answer. I don't have to know the term before it. For recursive, you have to know the term before it. So I define the first term. A1 is equal to 3/2. Then to find any other term, AN, I'm going to take the term before it, AN minus 1, and add 2/3 to it. Not 3/2, because your difference is 2/3. That's what you're adding to every term before it to get the next one. 3/2 is the first term, 2/3 is the difference. There's your explicit in recursive. Okay? So number 12 says, write a rule for each sequence, then find the indicated term. Okay, and on the key on one of these, oh, it was 16. On the key, I didn't finish the problem. The one that you were able to look at in class. All right, so the first thing I have to do is decide if it is arithmetic or geometric, right? So if I look at what's going on here, let's see, 33 minus 24 is going to give me 9. 42 minus 33 also gives me 9. So this is arithmetic. A1 is equal to 24. D equals 9. So AN is equal to 9 times n minus 1 plus 24. So that's equal to 9 times, 9n minus 9 plus 24. So I get AN is equal to 9n plus 15. So I have to have this part. These directions ask me for two things. It says write a rule, then find the indicated term. If it just said find the indicated term, then I wouldn't have to clean all this up and make it look pretty like that. I could just kind of substitute it in from the beginning. So now that I have that, I need A19. So A19 is going to be equal to 9 times 19 plus 15. So A19 is equal to 186. All right, so this next one. Again, if you take the time to figure out, we got to figure out if it's arithmetic or geometric. I'm thinking it's going to have to be geometric, because if I look at 3/2, there's no way I can add something to it to get to 9 and then add the same thing to 9 to get to 54. That's just too much, right? So since I know that it works, it has to work because it says write a rule. It's either arithmetic or geometric. 54 divided by 9 is 6, so R equals 6. A1 equals 1/4. It's geometric. So AN is equal to A1 times R, which is 6, to the n minus 1 power. There's my rule. I want to find A10, so A10 is equal to 1/4 times 6 to the 10 minus 1 power. That means A10 is equal to 2,519,424. All right, so the next one says, use the information given to find the indicated value. So I don't have to have a rule like boxed by itself, but I have to find the indicated value. I want A34. In order to do that, I have to use my little formula for my arithmetic. In order to use the formula, I have to have D, and then I have to have A1. I don't have that, but I can use this information to find it. So I can use A30, it's 213. That's equal to D, which is 8, times N minus 1, so that's 30 minus 1, plus A1. So this is going to give me 213 is equal to really 8 times 29. So it's going to be 232 plus A1. So A1 is equal to negative 19. Okay, that's not my final answer because nobody asked me for A1. They asked me for A34. So now to find A34, that's equal to the common difference, which is 8, times N, which is 34, minus 1, plus A1, or which is a negative 19, so I can do minus 19. So A34 is 245. All right, number 17. I have A1 and A23. I need to find the common difference. So do A23 is negative 16. That's equal to the common difference, which I don't know, times N, which is 23, minus 1, plus 28. So I can subtract 28 from both sides. That's going to give me a negative 44 is equal to D times 22. So the common difference is negative 2. And that's all they asked me for. I found that. Number 18. I have A1 and A39. I need to find A11. So it probably would have helped you if I had said on here that this is arithmetic, because otherwise you have to make an assumption. So I apologize for that. I take off the little titles sometimes, and I probably said arithmetic sequences up there. So this is arithmetic. It's probably what you did because the other two were, but it will be clearer on the test, I promise. All right, so I need to find A11. In order to do that, I have to find the common difference first. So A39, which is 752, is equal to the common difference, which we don't know yet, times N, which is 39, minus 1, plus A1, or minus 8. Okay. So I'm going to add 8 to both sides and get 760. That's equal to D times 38. I divide both sides by 38. The common difference is 20. So now I can find A11. A11 is equal to the common difference times N minus 1 plus A1, or minus 8. So A11 is 192. All right, now I need A27. It's along the same lines as that one right there. So I have A17. 77 is equal to the common difference times N, which is 17 minus 1, plus A1, which is 13. So I'm going to subtract 13 from both sides. I get 64 is equal to D times 16. So D is equal to 4. To find A27, that's equal to the common difference times N minus 1 plus A1. So A27 is 117. Okay. Next page. Number 20 it says find the indicated arithmetic means for each set of non-consecutive terms. So I'm going to have to fill in the blanks here. I want 6 means. So I'm going to start with 16, and then I have 1, 2, 3, 4, 5, 6 blanks, and then 65. Okay, that's just the part of some sequence that I have, and so this is the first term that I'm actually using. So this right here is A1, and this is 2, 3, 4, 5, 6, 7, 8. So this right here would be A8. Okay. So what I need to do, since it's arithmetic mean, I need to find the common difference so I can fill in the blanks there. So A8, which is 65, is equal to the common difference, which we don't know, times N, which is 8 minus 1, plus A1, which is 16. Subtract 16 from both sides, and I get 49 equals D times 7. So D is equal to 7. So my common difference is 7. So I take 16, I add 7 to it, and I get 23. Add another 7, that's 30, then 37, then 44, then 51, then 58. And if I added another 7, I'd be at 65. So there are the 6 means that are missing in there. All right, so number 21. I need 4 means in here. So I have 91 over 10, and then 1, 2, 3, 4, and then 48 over 5. So I'm using this as A1, 2, 3, 4, 5, A6. I need the common difference again. So 48 over 5 is equal to the common difference times 6 minus 1 plus 91 over 10. So if I subtract 91 over 10 from both sides, I get 1/2 equals D times 5. So the common difference here is 1/10. I'm going to take 91 over 10 and I add 1/10, and I get 45 over 6. Add 1/10, and I get 93 over 10, then 47 over 5, and then 19 over 2. And I add another one, I'll get 48 over 5. There we go. Okay, so now we're going to find the indicative value, and we are working with geometric now. So here's A1, and here is R, and I need A7. Okay, and it does not say that I have to write the rule, but if I did, you'd want to make sure you have it actually, stop with the ends in it and then continue. But I need A7. That's equal to A1, which is 3, times R, which is a -6, to the n minus 1 power, 7 minus 1 power. So A7 is equal to 139,968. All right, so I have A5 and R. I need A8, which means I need to find A1 first. So A5 is 1/4. That's equal to A1, which we don't know, times R, which is a -1/2, to the 5 minus 1 power. So if I actually take -1/2 to the 4th power, that's going to give me 1/4 is equal to A1 times 1/16, which means when I divide that out, A1 is equal to 4. Now I can find A8. So A8 is equal to A1, which is 4, times R, which is a -1/2, to the 8 minus 1 power. And A8 then equals 1 over 4,096. Oh, shoot. I just realized there's another mistake that I didn't fix, and this isn't even my mistake. Okay. All right, shoot. I probably already did this problem and did it differently. But on these directions, it says find the indicated arithmetic means. Well, that does not make any sense here. Well, I mean, I guess it kind of does, but you might have gotten answers. But this is geometric. We just did that, geometric. I didn't catch that. The other stuff is the weird stuff that disappears whenever I move things around. When I did this, I just did geometric because I knew what to do, but it says arithmetic. Dang it. All right. Well, there's no way you could have read my mind, I know. So if you already did these, I'm sorry, but do them on another sheet of paper so that you actually know how to do the geometric means as well. So I've got 3, and then I need 3 means in there. 1, 2, 3, and then 48. Okay. So this is A1. This is 1, 2, 3. Or, I'm sorry, 1, 2, 3, 4, 5. And this is A5. So I need to find R in order to figure out what the answer is here. So A5, which is 48, is equal to A1 times R to the n minus 1 power, 5 minus 1 power. So I'm going to divide both sides by 3, and I get 16. That's equal to R to the 4th. 4th root's pretty easy, even without a calculator. You just take the square root and take the square root again. Square root of 16 is 4. Square root of 4 is 2. So R is 2. Okay. And then That means that I'm multiplying by 2 each time. So 3 times 2 is 6, times 2 is 12, times 2 is 24, and here are my means. All right, so I have 12 and 4 over 81. So 12, and I have to have 4 means. 1, 2, 3, 4, and 4 over 81. So this is A1, and then 1, 2, 3, 4, 5, 6. I need to have R, so 4 over 81 is A6. That's equal to A1, which is 12, times R, which we don't know, to the 6 minus 1 power. So I divide both sides. Oh, this was where one of the other changes was, or not changes, but, well, sort of the fixes. The fraction bar disappeared. Ugh. And then, all right, so then I divide both sides by 12, and I'm going to get 1 over 243 equals R to the 5th. So R is equal to 1/3. So I take 12, multiply it by 1/3, I get 4. Multiply it by 1/3, I get 4/3. Multiply that by 1/3, I get 4/9. Multiply that by 1/3, I get 4/27. Multiply that by 1/3, I get 4 over 81. So there are my 4 missing geometric means. Ugh. All right, so now 28. We're moving on to the indicated sum, which means these are series, right? So the first thing you have to do is decide whether it is arithmetic or geometric before you can move on with that. And once you check out the differences here and see if you can figure out D or you can figure out R, try it by taking this minus this and this minus this. If that doesn't give you anything that matches, then this divided by this divided by this, right? So once you have figured that stuff out, you will see that this is arithmetic, okay, and that the common difference is -3/2, okay? In order for me to use the sum formula for arithmetic series, I have to have A1, which I do. A1 is equal to -19/5. I also need I need A18. So I got to find that. So A18 is going to be equal to the common difference times n minus 1 plus A1, which is -19/5. So you do all that to get that A18 is equal to -293 over 10. So now what I need in my formula for arithmetic series is I have to have n, A1, and AN. Well, here's A1, here's AN, and, well, n is 18. So the sum of those first 18 terms is 18, which is our n, times A1, which is a -19/5, plus AN, or A18, so that's plus a negative, or just minus 293 over 10, all over 2. You should be able to put all that in your calculator, and you will get that the sum of the first 18 terms is -2,979 over 10. Alrighty. 29. Got -405, -135, -45, so if I go through that and see that I'm actually dividing by 3, right, which means I'm multiplying by 1/3. So your R is 1/3, and that means that this is geometric. So for the geometric series, I have to know n, which I do, it's 7. I have to know A1, I got that, and I got to have R, right? This is A1. I don't care what A7 is, that doesn't come into play here. So the sum of the first 7 terms is equal to A1, which is -405, times 1 minus R, which is 1/3, to the n power, which is 7, all over 1 minus R. So the sum of the first 7 terms is equal to -5,465 over 9. All right, number 30. It's got sigma notation, but I want the sum of terms 1 through 14. This is clearly arithmetic, so I have to know, in order for that, I have to know what n is. N is 14 here. And then I have to know what A1 is and what AN is, right? So I need to find A1. A1 is going to be equal to 11 minus 8 times 1, which is going to give me 3. Then I also need to know what AN is, or A14. That's going to be 11 minus 8 times 14, which gives me a negative 101. So I have A14, I have A1, I have N. The sum of the terms 1 through 14 is equal to 14 times 3 plus a negative, or just minus 101, over 2. Which means the sum of the first 14 terms is negative 686. Okay, so I'm finding the sum again using sigma notation, going from 1 to 7, so n is equal to 7. This is clearly geometric, so I had to know a couple of things here without having to figure this out. This is another one where I think the fraction bar disappeared, so make sure that you put that back in there. And all right, so this negative 5 here, this represents A1. This 1/2, this represents R. So I have everything that I need to put into my series formula. The sum of those 7 terms is equal to A1, which is negative 5, times 1 minus R, which is 1/2, to the nth power, which is 7, all over 1 minus 1/2. So the sum of the first 7 terms is negative 635 over 64. All right, next page. So still finding the sums here, but this time I go from 2 to 9, and the number 4 disappeared. Those, if you were in class yesterday, then all those changes got made, but those of you that weren't, you didn't get those. I really don't know what the heck happened to this. 33 was even way worse than that. All right, so I'm going from 2 to 9. N is not 9, and N is not 7, right? N is going to be 8. So I need the sum of 8 terms going from the second term to the 9th term. I know that this right here is A1, and this right here is R, and this is geometric. So the sum of those 8 terms is equal to the first term. So A1, I technically don't want A1. This is not the A1 I want. I want the first term in the series, which is actually A2, so I gotta find that. So A2 is equal to 3 times a negative 4 to the 2 minus 1 power, and that's just gonna give me negative 12. So the first term in my series is A2, so that's negative 12 times 1 minus R is negative 4 to the nth power, which is 8, all over 1 minus a negative 4. So then the sum of those 8 terms there is 157,284. All right, so if you haven't already fixed 33, fix it, because there was numbers, there was all kinds of things missing, but this is what it should look like. All right, so I'm finding the sum of terms 4 through 13, right? So n is not 13, n is not 9. N equals 10. All right, so got that. This is arithmetic. So since it's arithmetic, I have to know A1 and AN. I have to know the first term and the last term. So I need A4, which is going to be 1/2 times 4 minus 7/6, which gives me 5/6. Then I have to know A13. That's equal to 1/2 times 13 minus 7/6, and that gives me 16/3. So even though this is A4 and A13 and n is 10, this is the first term in the series. This is the last term in the series. So the sum of those 10 terms is equal to the first term, or n rather, which is 10, times the first term, which is 5/6, plus the second term, which is 16/3, over 2. So the sum of those 10 terms is 185 over 6. All right, 34. This is infinite, okay? So I'm going from 1 to infinity. And negative 8 times 7/5 to the n minus 1, this is clearly geometric, right? So it's geometric and it's infinite. This 7/5 here, that is r. And here, r is greater than 1, which means that there is no sum here because this is divergent. Number 35, it's infinite again. This is geometric. This is A1. This is r. Here, r is less than 1. And remember, it's the absolute value both times on these. These just both happen to be positive. But the absolute value is less than 1, which means this is convergent. So I can find the sum. And I don't use this formula. I use the infinite formula that says the sum is equal to A1, which is 3/2, times 1 over 1 minus r, which is 3/4. So the sum of those infinite terms is 6. It converges to 6. Alrighty. 36. In 2004, the moose population in a certain area was counted at 1,700. Since then, the population has decreased by 6% each year. In which year will the population drop below 1,000? Okay, so 1,700, that's going to be A1, right? R is going to be equal to, if it drops 6% each year, that means there's only 94% as much, so 0.94 is my R. I'm looking for N, basically, so I know that 1,000 is kind of my goal here, so AN is equal to 1,000. And then I'm going to figure out in what year that happened, or how many years it's going to take for that to happen so that I can then take care of that 2004. Because whatever N gives me is not going to be my answer in the end. So AN is 1,000. That's equal to, and this is geometric, right? Because it's going to be decreasing that way. So I've got 1,700 times R, which is 0.94, to the N minus 1 power. Okay, so I'm going to divide both sides by 1,700, and that's going to give me 10 over 17 is equal to 0.94 to the N minus 1 power. I need to get N out of the exponent, so I'm going to have to take the log of both sides. So the log of 10 over 17 is equal to, well, that's not a 17. 10 over 17. When I take the log over here, the exponent comes out front, but there's parentheses times the log of 0.94. Now, whether you use natural log, common log, it doesn't matter, as long as they're the same on both sides. So before I do anything in the calculator, I would go ahead and divide both sides. So I'm going to get the log of 10 over 17 over the log of 0.94 is going to be equal to N minus 1. So we'll go ahead and calculate this. And that's going to give you 8.576 equals N minus 1. So N is equal to 9.576. So that means that it's going to take about 9.5 years for it to drop below 1,000. So if I add that 9.5 years, that means it would be about halfway through 2013. And it just says in which year, so the answer is 2013. All right, Janet was hired as a lifeguard with a starting wage of $6.25. If she receives an 80-cent raise annually, how long will it take for her salary to double? All right, so this is arithmetic. It is not geometric. And when her salary doubles, that means AN, which we're looking for because we want to know N. When I double that 625, that's going to give me 1250. It's going to change by 80 cents because I'm adding that 80 cents, right? Oh my goodness. That's D, I'm sorry. D is equal to 0.80, okay, because that's the common difference. You add 80 every year. And how long will it take for her salary to double? Well, A1 then, there is 625. Okay, so we set this up. I have AN, it is 1250. That's equal to the common difference, which is 0.80, times N, which we don't know, minus 1, plus A1, which is 625. So when I subtract 625 from both sides, I'm going to get 625 is equal to 0.80 times N minus 1. Divide both sides by 0.80, and I get 7.8125 is equal to N minus 1. So then I get 8.8125 is equal to N. So got to think about this. She receives an 80-cent raise annually. If it's going to take over 8 years for that to happen, that means it's not going to be doubled until that 9th year. So the answer is 9 years. It also won't be exactly doubled. It would be a little bit more. All right, number 38. Eric is training for a trail race. He ran 4.1 miles on the first day, 4.5 miles on the second day, 4.9 miles on the third day. If the pattern continues, find the total mileage, that means this is telling me it is a series, after 45 days. Okay, so A1 is equal to 4.1. He is adding 0.4 miles every day, which means that this is arithmetic, so the common difference is 0.4. I need N is 45, right? But also to do an arithmetic series, I also have to know AN, so I need to know A45. That's going to be equal to the common difference, which is 0.4 times N minus 1 plus A1. Right? So once I work all that out, I get that A45 is equal to 21.7. All right, so now I substitute that in over here. S45 is equal to N, which is 45, times A1, which is 4.1, plus 21.7, which is A45, all over 2. So the sum of that is equal to 580.5 miles. All right, a savings account. Started with a deposit of $1 on the first day of the month. The second day, $2 was deposited. The third day, $4 was deposited. And find the total amount in the account after 20 days. So we are doubling the deposit every day. A1 is equal to 1. N is equal to 20. R is equal to 2. So for a geometric series, that's all I have to know. So the sum of those 20 days is going to be equal to A1, which is 1, times 1 minus 2 to the 20th power over 1 minus 2. That means after 20 days, if she's able to pull this off, she will have $1,048,575. All right, now, we're going to expand with Pascal. Okay, so we're going to expand each expression using Pascal's triangle or the binomial theorem. Okay, so with Pascal's triangle, you have to actually write the triangle out, which I guess you can do that if you want to, but the binomial theorem does make it a little bit easier. I mean, I guess that's a matter of opinion. But up here, if I wanted to, I would need to get to the 8th row of Pascal's triangle, so it would be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1, and then 1, 8, 28, 56, 70, 56, 28, 8, 1. So there's the 8th row, and you got it, right? You can write it all out, you can figure it all out if you want to, but you also have to know how to do the binomial theorem. So maybe we'll do one way and one the other way. So it says expand each expression using Pascal's triangle. So we'll do Pascal's triangle first. So if I'm going to use this 8th row here, right, my very first coefficient is 1 from right here. Then I take this a, which is x, to the 8th power, times that negative 2y to the 0 power, plus, then I use 8. 8 times x to the 7th times negative 2y to the 1st, plus, then I use 28. 28 x to the 6th times negative 2y to the 2nd, plus 56 times x to the 5th times a negative 2y to the 3rd, plus 70 x to the 4th negative 2y to the 4th, plus 56 x to the 3rd negative 2y to the 5th, plus 28 x to the 2nd negative 2y to the 6th, plus 8 times x to the 1st times negative 2y to the 7th, plus 1 times x to the 0 times negative 2y to the 8th. Remember to go back and double check yourself that these are actually the coefficients that come from that line of Pascal's triangle. And then also that your exponents each time add to give you 8. Now you gotta work it all out and clean it up. So in this first term, these are both just 1, so it's just x to the 8th. And then I have negative 2y to the 1st, so it's a negative 2 and an 8, so it's negative 16 x to the 7th y. Then I'm going to have negative 2 squared, which is going to be 4 times 28. That'll give me 112 x to the 6th y squared. Okay, and so forth and so on. The signs will alternate here because it's negative and we're changing the exponents from even to odd each time. So I'm just going to write out the rest of this. Negative 448 x to the 5th y cubed plus 1120 x to the 4th y to the 4th minus 1792 x cubed y to the 5th plus 1792 x squared y to the 6th minus 1024 x y to the 7th plus 256 y to the 8th. And there is your ginormous expansion. Okay. All right, so we're going to do the next one with the binomial theorem, which just means we don't have to write out Pascal's triangle and know it in its entirety here. So this is 5, right? So that means I'm going to start with 5. So our row number is 5. Row equals 5. All right, so 5, 0. And then I take a, which is 4x to the 5th, and then negative 1 to the 0. Then it's going to be a combination that's 5, 1, and I'll have 4x to the 4th, negative 1 to the 1st, plus do the combination of 5, 2 times 4x to the 3rd times a negative 1 squared, plus 5, 3, 4x to the 2nd, negative 1 to the 3rd, plus 5, 4, oops, not a fraction, 5, 4, 4x to the 1st, negative 1 to the 4th, plus 5, 5, 4x to the 0, negative 1 to the 5th. Okay, so remember, we're doing this one. Don't even look at that triangle, because the idea here is that we don't have the triangle or we don't want to write it out or whatever. But here's some things you should know. You should still know how it relates to the triangle, meaning that this very first one here, right, the very first coefficient is going to be 1 every time. So you can do that combination on your calculator. Remember, you use that NCR button. Okay, this would be 5C0. It'll give you 1 when you do it. And we also know that the last one is always 1. It doesn't matter what n is. Now, your row number, this is row 5. So the second number is 5. This combination of 5, 1, it's going to give you 5. And the second to last one is 5 also. That doesn't mean that it's, because if you notice up here, it's not like this is 1 and 8 and 8 and 1, because there's other numbers that are mixed in there. But the coefficient that you would get from the triangle is that. So really, on this one, you only have 2 combinations that you would have to do, which is probably easier than writing out the whole triangle every time you got to do it. And then when you do this and find these numbers, keep in mind that you have other numbers going on in here. So like, when I do this very first term here, well, this is 1. Right? But then I also have to take 4 to the 5th and negative 1 to the 0. So that's just 1. But 4 to the 5th power is going to give me 1024. So it's 1024 x to the 5th. Then I'm going to have 4 to the 4th times 5 times a negative 1 is going to give me negative 1280 x to the 4th. Plus, then when you do this combination, multiply it by 4 cubed, and then a positive 1, you're going to get 640 x cubed. You do this combination in the calculator, times 16 times a negative 1. It's going to be negative 160 x squared. Plus, and then this is going to be just 5 times 4 times a positive 1, so that's 20 x, and then this is to the 0 power. This is going to give me a negative 1 times 1, just minus 1. And there you go. Okay. Good to know the binomial theorem or the binomial expansion here for you to find the indicated term. So you don't have to find the entire thing and figure it out every time, right? In order to do this, we have to know n. N is equal to 7. It's also the row number. The term number is not r. Okay, r is the element number, and remember that the element starts with 0. So if I want the 5th term, I really want the 4th element. Okay, so row 7, 4th element. Okay, and again, don't go looking back up there at that triangle because you're not going to have it all written out. What I want to do here then is, this is 7, 4 combination. Then I take a, which is 3k times, to the 7 minus 4 power times 2 to the 4th power, right? So this becomes 3 right here, really, right? Really, that's 3. And so when I do the combination of 7, 4, that's going to give me 35 times 3 to the 3rd is 27. Then we have k cubed. And then 2 to the 4th is 16. So in the end, what we get is 15,120 k cubed. Okay. Number 46. I want the 8th term. N is equal to 11. R will be equal to 7. So I need a combination of 11, 7. I'm going to take x to the 11 minus 7 power times a negative 3y to the 7th power. So this is really 4 right there, right? So do the combination of 11 and 7. That's going to give me 330. And then this is going to be x to the 4th. And then I get negative 3 to the 7th. It's going to be times a negative 2187. When I multiply all that together, I get negative 721,710 x to the 4th, y to the 7th. Oh, I forgot my y to the 7th. And there we go. All right. Now this one. I need the 14th term. And this means that n is equal to 18, r is equal to 13, because it's the 13th element. So I do the combination of 18, 13. Then I do 2c to the 18 minus 13 power times a negative d to the 13th power. Okay. This here is 5. Okay, I mean, you can start off by writing 5 if you want to. I just want to make sure you know where this is coming from. I do this combination here, and I get 8,568 times 2 to the 5th is 32c to the 5th. I can't just ignore this. Negative d to the 13th power is going to be negative d to the 13th power. So that gets, and then when I multiply all that together, that's going to give me a negative 274,176 c to the 5th, d to the 13th. Watch your signs. All right, back to vectors. It says give the magnitude and direction angle for each angle, right? You have the vector in, remember this is component form. I have component form. In order to find the magnitude of P is just equal to the square root of 3 squared plus 9 squared. So that's going to give you 3 square root of 10. The direction angle, theta, is equal to the tangent inverse of y over x, 9 over 3. So it's the tangent inverse of 3. That gives me theta of 71.5, right, 71.565. But you have to pay attention to your quadrants. Don't be missing all these because you don't know what quadrant you're in. This would be directed towards the first quadrant. This is a first quadrant angle, so I'm good. It's 71.565 degrees. All right, number 12. The first thing I have to do is put this in component form. So in order to do that, and the order matters here, some of you did these backwards on your vectors quizzes. This is UV, so it has to be V minus U. So negative 5 minus 1 is negative 6. 9 minus 5 is a positive 4. So the magnitude of UV is equal to the square root of negative 6 squared plus 4 squared. That's 2 square root of 13. Then theta is equal to the tangent inverse of 4 over a negative 6. And that gives me negative 33.690. Can't have a negative angle. This is negative 6, positive 4, right? So this angle right here is a fourth quadrant angle, negative 33 degrees. I want to be in the second quadrant, so I just add 180 to this, and I get 146.310. Do not miss these because you are not paying attention to the quadrants. 13. All right, so again, I have to find the component form. So negative 3 minus a negative 8 is going to give me a positive 5. Negative 1 minus 5 is going to give me a negative 6. All right, so I find the magnitude of Mn. That's equal to the square root of 5 squared plus a negative 6 squared. That magnitude gives me the square root of 61. Theta is equal to the tangent inverse of negative 6 over 5. Calculator gives me a negative 50.194. Okay. So that means the angle that the calculator gave me is a negative angle, and it is here in the fourth quadrant. This 5, negative 6 means my vector is directed towards the fourth quadrant. So I want a fourth quadrant angle. It just can't be negative, so I add 360 and get 309.806 degrees. All right, number 14. I can find my ordered pairs, and I can find my component form that way, but I can also see that my vector is directed this way, right? So in order to get from this point to this point, I would have to go to the right 3, 1, 2, 3. So I have a positive 3, and then down 1, 2, 3, 4, 5. So that's a negative 5 for the y. Find the magnitude of k. That's equal to the square root of 3 squared plus a negative 5 squared. Magnitude of k, square root of 34. Angle theta is equal to the tangent inverse of negative 5 over 3. Calculator gives me negative 59.036. All right, well, this is a fourth quadrant angle because it's negative. This is directed towards the fourth quadrant, so I want the fourth quadrant angle, just not negative, so I add 360 and get 300.964. Okay, now we're going to look at vector operations. Let's find each of the following. So they have defined vector A, B, and C for us, and we just want C plus A. This is a piece of cake, right? So you take C, which is negative 6 plus 4 for A, and then the y term, I'm going to take 2 plus a negative 1. So C plus A is equal to negative 2, 1. All right, then 2b minus 5a is going to be 2 times 3 minus 5 times 4, and then 2 times 5 minus 5 times a negative 1. So that means 2b minus 5a is equal to, so it's going to be 6 minus 20, so that's a negative 14. And then 10 plus 5 is going to be 15. Okay, negative a plus 1/2 c, so negative 4 plus 1/2 times a negative 6, and then a negative 1 plus 1/2 times 2. So negative a plus 1/2 c is equal to, so half of negative 6 is negative 3, so that gives me negative 7. That's going to be a positive 1 plus a 1 is going to give me a positive 2. All right, so now we are looking for the unit vector. Unit vector with the same direction. In order to find that, I first have to find the magnitude. Okay, so I find the magnitude of f, magnitude of vector f, is equal to the square root of 11 squared plus 4 square root of 3 squared. That gives me 13. So the magnitude is 13. The unit vector is equal to 1 over the magnitude times the vector 11, 4 square root of 3. So that means that the unit vector is 11/13, 4 square root of 3 over 13. All right, so here, I just realized something else that disappeared here is PQ, but I guess we've kind of figured that out anyway. So PQ. And so if I need to find the component form first. So my component form is going to be 3 minus 15, which is negative 12. And then 18 minus a negative 17 is going to give me a positive 35. Which means that the magnitude of this vector that you didn't even know the name of is equal to the square root of negative 12 squared plus 35 squared. And that's going to give me 37. So the unit vector is equal to 1 over 37 times negative 12/35, which means your unit vector is equal to negative 12 over 37, 35 over 37. And there's nothing you can do to simplify that. All right, so now we're looking for the component form of each vector with the given magnitude and direction. So I'm giving you the magnitude and direction. You got to find the component form, the pointy bracket form, right? So this is, remember, this is just like your r cosine theta, r sine theta. The r is the radius, it's the magnitude, it's just, it's kind of all the same thing depending on how you're applying it. So to find my component form here for D, that's going to be equal to 12 times the cosine of 330, and then 12 times the sine of 330. Okay. Considering that these are special angles, I expect exact answers here. So this would give me 12 times square root of 3 over 2 and 12 times a negative 1/2. So the vector then is 6 square root of 3, negative 6. You kind of luck out since I'm letting you use those calculators, kind of does it for you. But you still have to know what to do. All right, so then to find V, this is equal to 8 cosine 215, 8 sine 215. So V is equal to negative 6.553 and negative 4.588. Those are the two components in there. That one, not a special angle. Okay. So now we're supposed to write these in trigonometric form. All right, so the first thing I have to do is put it in component form. So this is in my IJ form. Component form is just negative 2, 6. It's that easy. All right, so to write it in trigonometric form, I have to find the magnitude and the angle. So the magnitude of n is equal to the square root of negative 2 squared plus 6 squared. And that gives me 2 square root of 10. Theta is equal to the tangent inverse of 6 over negative 2, which the calculator gives me negative 71.565, but pay attention to your quadrant. This right here is a fourth quadrant angle. This negative 2, 6 is directed towards the second quadrant. So I need to add 180, and then theta is actually 108.435. So my trigonometric form, when it says in trigonometric form, that means you have trig words in your answer. So it looks like this. N, the vector, is equal to 2 square root of 10 cosine of 108.435, comma, 2 square root of 10 times the sine of 108.435. Trigonometric form has trig in it. All right. So here again, got to find component form first. So negative 4 minus a negative 5 is going to give me a positive 1. 6 minus 2 gives me 4. Okay. So magnitude of xy is equal to the square root of 1 squared plus 4 squared, which is the square root of 17. Theta is equal to the tangent inverse of 4 over 1, which is a tangent inverse of 4, and that gives me 75.964 degrees. All right, this is a first quadrant. It's directed towards the first quadrant. This is a first quadrant angle, so that actually is my angle. So vector xy in trigonometric form is square root of 17 times the cosine of 75.964, and then the square root of 17 times the sine of 75.964 degrees. And degrees here too. All right. Last page. Mother is pushing a stroller with a force of 30 pounds uphill at an angle of 25 degrees. Okay, so my vector is going uphill at 25 degrees. Give the force exerted on the lawnmower. Oh, good Lord in heaven. Okay. There is, yeah, it's not a lawnmower. It's a stroller. Sorry, make myself laugh here. And so what I'm looking for is the resultant force here. they gave me the resultant force. Sorry, I was laughing at myself and then sneezing, but I think I paused it before that happened. That's my force, right? So that's 25 degrees. This is that 30 pounds. Okay, so what I want is I want this in component form. So basically I'm looking for the x and y components that go with it. So I have the angle and I have the magnitude. I want to find it in component form. So that's your r cosine theta, r sine theta. So the vector is equal to the magnitude, which is 30 times the cosine of 25, and then 30 times the sine of 25. And that's all it is. So that gives me, and it doesn't say in trigonometric form, so I don't get to leave it like that. I have to actually type that in and get 27.189, 12.679. There is the force exerted in component form. Okay, it's not the resultant of the vector. All right, a sailboat is traveling at 6 knots at a true bearing. True bearing of 220. Give the velocity of the sailboat as a linear combination, which means I got to find the component form first, of unit vectors I and j. All right, so the first thing we want to do is figure out this bearing thing. Remember that bearing starts here at 0. This is 0, and it rotates this way. So this is 0, 90, 180. This is 270, so 220 is down here. 180 plus 40 is 220, so it'll be somewhere right about here. Okay, so this right here is 220 degrees. In order for me to do this, I have to have theta. So theta starts at 0 here and rotates around this way. So there's a couple different ways to do this. If I want to go from here to here, I know from here to here is 180. If this coming this way would be 270 and this is at 220, there's 50 more to go right there. So 50 and 180 means theta is actually 230. Okay, so I got my theta. The resultant, the vector, it is 6 knots. This is 6 knots. So that means that the vector is equal to 6 times the cosine of 230, 6 times the sine of 230. So I'm going to find it in component form first, and that's going to give me negative 3.856, negative 4.596. But it does say, as a linear combination of vectors I and j, so the vector then in that form is negative 3.856i plus negative 4.596j. Notice there's no pointy brackets. You don't mix the two. This is an addition statement. This is an ordered pair. Make sure you can actually do those things correctly. All right, so now let's look at resultant force and velocity. Two forces with magnitudes of 115 and 160 are acting on an object at angles of 50 and 130 respectively with the positive x-axis. So that means those are theta. Find the magnitude and direction with the positive x-axis of the resultant force. So this is talking about theta 100% of the time. Okay, so I've got two forces. They are 115 pounds and 160 pounds, and our angles are 50 and 130. So 50 degrees is about right here, and this is 115. And then 160 be right about here. Oh no, I'm sorry, that's 160 pounds. Angle is 130, so it would be more like right here, and it's 160 pounds. Okay, so from here to here is 130 degrees, and then this is 160 pounds. Okay? So I want the resultant force. Now remember, that's just drawing them, just the two vectors, just to have an idea of what's what, and we can figure out the angles. I didn't actually put them end to end. You totally can. I'm going to do them kind of two different ways here so that you can remember what to do here. All right, so so we have the first one, and so we have force 1 and force 2. So we'll just do vector 1 is going to be 115 times the cosine of 50, 115 times the sine of 50. Vector 2 is going to be 160 cosine of 130, 160 sine of 130. Remember, I want the resultant, so I'm going to add these two together. I literally add them together. So V1 plus V2. And in your calculator, you go ahead and type this in and store it. So 115 cosine 50, close parentheses, plus 160 cosine 130 equals shift store X, right? And this gives you negative 28.925. Then you do 115 sine 50, plus, close parentheses, plus 160 sine 130 equals shift store Y. And you get 210.662. Okay, so that's not my final answer, just what I have to get at this point. Then I have to find the magnitude, right? So to find the magnitude of V1, V1 plus V2, that's equal to the square root of x squared plus y squared in your calculator. You literally type that in. As long as you stored your numbers, you are good to go. And you are going to get 212.639 pounds. That's your resultant force, rather. Then I need theta. Theta is equal to the tangent inverse of y over x. And in your calculator, that's literally what you put if you stored it correctly. That's going to give you a negative 82.182. So you need to then decide, you know it can't be negative, so figure out what we want to do with this. Here's my resultant vector, right? It is directed towards it's negative positives, directed towards the second quadrant. This is in the fourth quadrant. So to get there, I add 180, and then my theta is going to be equal to 97.818 degrees. Okay, so now we have two pulleys lifting a statue. One is pulling with 575 newtons of force at an angle of 35 degrees to the left of the statue. Okay, so we've got 575 newtons at an angle of 35 degrees to the left of the statue. So remember, this is just like one of those angles they're just making up. So here's 35 degrees to the left of the statue. And then the other one, and this is 575 newtons. The other one is pulling at an angle of 30 degrees to the right at 700 newtons. Find the magnitude and direction angle of the resultant force. Okay, so we have pulley 1 and pulley 2, right? So P1, the theta for P1, right? So my pulley 1 was the 575. This is 35 degrees right here. Theta starts here, so I have to add 90. So that's going to be equal to 125 degrees. Then theta for P2, well, this is 30 degrees, and I start here, so I have to subtract that from 90, and that gives me 60. So for pulley 1, my vector is going to be 575 times the cosine of 125, 575 times the sine of 125. Right. For pulley 2, that's going to be equal to 700 times the cosine of 60, and then 700 times the sine of 60. So then I add them together in my calculator. P1 plus P2. Remember to store these when you do this, and you will get 20.194 and 1077.230. Right? So I want the magnitude. Magnitude of pulley 1 plus pulley 2 is equal to the square root of x squared plus y squared. And you get from that 1077.419 newtons. And then theta is equal to the tangent inverse of y over x. That gives me 88.926. Right, well, this is my resultant right here. It's directed towards the first quadrant. That's a first quadrant angle. So my theta is 88.926 degrees. Okay. Now we have an airplane traveling at a speed of 450 miles an hour. Oops. At a direction of north 54 degrees west. Okay. So it's going north 54 degrees west, like so. So this is 54 degrees right here. This is 450 miles per hour. And then it hits a wind traveling with a velocity of 55 miles per hour in the direction of south 70 degrees west. So these I'm going to put end to end, and I'm going to go south 70 degrees west. And it's only 55 miles per hour, so it's a lot shorter. So this right here is 70 degrees, and this is 55 miles per hour. So I need theta for the plane, and I need theta for the wind. Okay, so the plane here, right? Theta starts here. This is 54 degrees. This is 90. So 90 and 54, that would give me 144. For the wind, this is 70, right? Theta starts here and comes around. Well, that's 180. And then if this is 70, it has 20 more to go to get up here. So that means it's going to be 180 plus 20. That's 200 degrees. There are my thetas. Okay. So when I draw in my resultant here, oh, I have too many arrows. Okay, these are the vectors, and then that was just pointing to the 70 degrees. But this is my first vector right here. This is my second vector. So my resultant looks like this. Okay. So for the plane, this vector is 450 times the cosine of 144, 450 times the sine of 144. For the wind, that's equal to 55 times the cosine of 200 and 55 times the sine of 200. Okay. So you put this in the calculator, you add them and store them, and you get that resultant vector is equal to negative 415.741, comma 245.692. I think. I can't read my own handwriting. That's either a 2 or a 3. All right. So here's my resultant vector. I need to find the magnitude of that. That's equal to the square root of x squared plus y squared, because it should be stored in my calculator. And that gives me 482.913 miles per hour. That's one you can't read. Then I need theta. Theta is equal to the tangent inverse of y over x. The calculator gives me negative 30.582. Okay? Now, pay attention to the fact here that this says find the magnitude and direction as a true bearing. Okay, so got to think about what's happening here. First of all, this angle is down here in the fourth quadrant. This resultant vector is directed towards the second quadrant. I want a true bearing that starts here and gets me all the way around to here. So I think you have a couple of options on how you do that. Okay. One option is to go ahead and figure out what theta is and then go from there. Or you could figure out how to get to here as a bearing, which I think that's what I would probably do with that. In this case, that's what I want to do. So if this right here is negative 30, right? That's negative 30 degrees, blah, 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 as theta. Well, bearing starts here at 0. So if I use that as a positive 30.582 and add that to 90, then as a true bearing, I get 120, blah, 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 right? But I'm here, and I still need to get another halfway around. So from here is the true bearing. I can add another 180 to actually get me here where I want to be, and my true bearing in the end then is 300.582 degrees. There you go.